In this video, we will look at what makes a well-designed computer system, i.e. a computer program, and what constitutes a well-designed Python function. In addition, recommendations for good function design are also given. Let's consider a structure chart, and it's one we've looked at in the previous two videos in this playlist, and it's about issuing wage slips. And what this particular structure chart is going to represent is the design of a computer system, i.e. a computer program, that's going to display the name and the net pay of every employee in the company. Now, to achieve this, it's going to call modules, and these modules, I'll keep on referring to them as modules, but they will become the functions in Python if we decide to implement the structure chart in the Python programming language. Now, the first thing this particular module is going to do is to call another module called getEmployeeRecord. Now, what getEmployeeRecord is going to do, it's going to read from an appropriate file system information on a particular employee referred to as their record. Now, this record is going to contain information about the employee, such as their rate of pay per hour, how many hours they've worked, what their name is, and information about any deductions that have to be taken away from their salary. The next thing that's going to happen, the issue wage slip is going to call, and it's going to call another module called calculate net pay. And to this module, it's going to send the record. Now, the calculate net pay is going to use the information inside the record to return the net pay. Now, to achieve the returning of the net pay, what the calculate net pay module is going to do, it's going to call another module called calculate gross pay. And to this, it's going to pass the pay rate and it's going to pass the hours worked. Now, it got that information out of the record because if you remember, the calculate net pay was sent the record, so the calculate net pay is able to extract information that relates to the pay rate and the hours worked from the record. What the calculate gross pay is now going to do, it's going to use the pay rate and the hours worked, multiply them together to give the gross pay, and this gross pay is now going to be returned to calculate net pay. The calculate net pay module is now going to call another module, and this module is going to be calculate deductions. Now, if we're going to calculate the deductions, it's always based on what the gross pay is, so we will have to send the gross pay from calculate net pay to deductions. And of course, the calculate net pay knows what the gross pay is because it's just been given it by the calculate gross pay function. In addition to the gross pay being sent to calculate deductions, we also send the tax details, which have been extracted from the record. Now what will happen, the calculate deductions module will work out what the deductions are and will pass that back to the calculate net pay. Now, the calculate net pay will receive the gross pay from the calculate gross pay module, and it'll receive the deductions from the calculate deductions module. Consequently, it can calculate the net pay, which it promptly sends back to the issue wage slips. And of course, if we're going to calculate the net pay, it's the gross pay minus the deductions. What issue wage slips will now do, it'll call another module, and this module is called display wage slip. And to this, we're actually going to send the name of the employee, which is taken from the record, which issue wage slips has a copy of because it was responsible for getting the record from getEmployeeRecord module. But in addition, it'll send the net pay that it's just actually got from the calculate net pay module. And this now represents a design for a computer program that will display the name and net pay of an employee. The structure chart is designed to show how modules call each other and pass each other these data couples. And we saw in the previous video we can now choose an individual module and code that as a Python function. What I want to do now, however, is to ask a number of questions about this design. For example, can I get rid of any of the modules? Well, the answer is I am going to. I'm going to get rid of this one here, issue wage slips. And I'm going to move this calculate net pay up to where the issue wage slips is. And I'm going to see how the data couples will then move through the new structure that I'm going to create to implement the same specification, namely issuing the wage slips, which will display the employee name and the employee net pay. So if we have a look at the new structure I'm going to produce, we're going to start off with the calculate net pay. Now it is actually now going to call the get employee record, and the get employee record will go to an appropriate file system and will return the record to the calculate net pay. The calculate net pay is then going to call the calculate gross pay, and at the same time it's going to send it the pay rate and the hours worked that have been extracted from the record. And of course the calculate gross pay is going to actually work out what the gross pay is from the pay rate and the hours worked, and it's going to send that back to the calculate net pay module. The next thing to be called will be the calculate deductions module. And to this we're going to send the gross pay that's just been calculated together with the tax details that's been extracted from the record. And of course the calculate deductions will now calculate the deductions and return it to calculate net pay, and the calculate net pay will now call the display wage slip module, sending it the net pay that's just been calculated together with the name. And now, of course, the net pay was calculated inside the calculate net pay module from the gross pay and deductions that were returned to it. Now, this structure chart is slightly different from the previous one, but it implements the specification. So we can see here we actually have one less module. Now I'm going to redesign the structure chart again, and I'm going to start off with this one here, which says get record, calculate net pay. So this is a module that does two things, and within here there's going to be code that will go to the file system and will get the record on the current employee. In other words, it doesn't have a separate module for getting the record of the current employee. It will also calculate the net pay. But what I'm going to do in my structure chart, I'm going to have it call a module which is called calculate gross pay. And to this, I'm going to send the pay rate and the hours worked. Now, of course, that would come from the record that was got from the code inside the get record calculate net pay module. And the calculate gross pay will now return the gross pay. The next thing to happen is we're going to call the calculate deductions. And to the calculate deductions, we're going to send the gross pay and we're going to send the tax details which were extracted from the record. And of course, we can't see any data couple for the record because it's inside, it's the code inside this module that gets the record. And it will be a local variable in this module which will store the actual record. So we don't see that appearing as a data couple. Now the calculate deductions module will do precisely that, calculate the deductions and return it to the get record calculate net pay module. The next thing to happen will be a call to the display wage slip, and to this we will now send the net pay, which has just been calculated inside this module by the code inside this module, together with the name which is being extracted from the record. And that record, of course, is a local variable inside this module. Now what we have a different structure chart, but this structure chart will still implement the specification we've been considering. I'm now going to implement the specification using a different structure chart design as shown here. The first thing we're going to have is get record, calculate net pay. Now that's like the one we've just looked at, but the difference here is I'm going to have this calling a module that calculates the gross pay and deductions. Now this was done separately a moment ago, but what I'm deciding here is this function is going to calculate the gross pay and the deductions. So to help it do that, we're actually going to send the pay rate, the hours worked, and the tax details, all of which would have been extracted from the record which was stored in a local variable in this module. And of course, what this particular module is now going to do, it's going to calculate the gross pay and the deductions, and it's going to return the gross pay and the deductions to the get record calculate net pay module. Then we're going to have a call to display wage slip. To this, we're going to pass the net pay and we're going to pass the name. Now this structure chart will still implement the specification, and we can see we only have 3 modules. One of the things we can note, however, we seem to have a lot of data couples here. Now this has an implication to the overall design of our computer system. I'm now going to design the program again using a structure chart, and we can see here that I'm going to have a module, and this module is going to get the record, it's going to calculate the net pay, and it's going to display the wage slip. Now earlier in this video we saw a structure of a design where the get record was a separate module, the calculate net pay was a separate module, and the display wage slip was a separate module. Here, however, we're having all of the code for doing the getting of the record, the calculating the net pay, and displaying the wage slip inside here. However, I am going to have this calling a module, and the module it's going to call is calculate gross pay and deductions. Now if we have a look at this module, we can see it's doing two things. It's calculating the gross pay and the deductions. And of course, to allow it to do this, we need to send it the pay rate, we need to send it the hours worked, together with the tax details. And what now is going to happen, this module will return the gross pay together with the deductions. When this module now receives these two data couples, it's going to calculate the net pay. Once the net pay has been calculated, it's going to display the wage slip. And of course the displaying of the wage slip will be the displaying of the net pay which has been worked out inside this module, together with the name which has been taken from the record that was found by the code inside this module. We can now look at another design, and it's the final one I'm going to suggest as a design, and it's this one here. And this is where we have one module, or if you like one program, that gets the record, calculates the gross pay, calculates the deductions, calculates the net pay, displays the wage slip. And all the code for doing that is inside this module. Now, the trouble with this particular module or design, and I use the word design loosely when I describe this, is it's very difficult to test because it does too many things. Far better to decompose the design so that the decomposition leads to modules that are doing something simple, such as getting the record, such as calculating the net pay, such as displaying the wage slip. Now let's have a look at all the designs side by side that we've gone through in the video so far. The structure charts we've been concerned with are the ones that are appearing on the screen. Now all of these designs have one thing in common. They can all implement the specification. And so long as you actually are careful when you write the code, you can actually get all of these designs to implement the specification 100%. The thing is, which of these are better designs? And by better, I mean things that are going to be easier for us to test, because one of the things when you're writing code is you have to make life easy for yourself. You have to show that your program performs its task accurately. And one of the ways of doing that is to test as you're going along. And one of the better ways to actually perform this testing routine is to get functions that are relatively easy to test. So if I have a look at these designs here, the one I don't like is this one here, because this is a module that does too many things. These two are the ones I'm relatively happy with, and let's go on to have a look at why that is the case. And we're going to do that by concentrating on an individual function and deciding what it should look like in terms of what it does, i.e. what task it performs, and what data couples it actually will be dealing with. With respect to modules, in other words functions, cohesion refers to the degree to which the functional parts of the function belong together. Let's see if we can put something onto the bones of this statement. Let's have a look at this example here. Here we've got a module that calculates the gross pay. Now, that module is cohesive. What does it do? It does one thing. We can see quite clearly what that's about. And for this module, I can send it 2 bits of data and I expect the 1 bit of data back. And it's cohesive, it's strongly cohesive, I would say, because it's clear what it's doing. If we have a look at this module here, It's calculating the gross pay and it's calculating the deductions. Now it is doing two tasks, and those tasks kind of relate to each other logically because it is doing something with people's pay. But the trouble with it, it's actually doing two things. If we have a look at another example, this one here. Now this is a module, and this one gets the record, it calculates the gross pay, it calculates the deductions, it calculates the net pay, it displays the wages. Now cohesively, they don't really hang together well. There's too many things in there that's doing. It's got too many tasks it's carrying out. So I don't like that design there. So looking at these, I would say this is a good design. This one here, it's not as good. And this one, well, I think is dreadful as a design. And the reason being, you see, it's easy to test this one. You say to it, right, well, I'm going to stick the pay rate in and the hours worked, and I'm going to get the gross pay back. With this one, you've got to put in the pay rate, the hours worked, and the tax details, and you're going to get the gross pay and the deductions back. So that's a little bit more tricky to test. This one is a pain to test. You know, you've got to see if it gets the record. You've got to see if it calculates the gross pay. You've got to see if it calculates the deductions properly. You've then got to see if it calculates the net pay properly, and then display the wage slip. So that's more difficult to actually test, because this one can be treated as a black box in the sense that you don't actually need to know what's inside it. You're just saying, right, well, I'm going to give it this data, I'm expecting this back. So you can test it more readily, more easily. Data coupling is the manner and degree of interdependence between software modules, i.e. between functions. Let's see if we can put something onto the bones of this particular statement. What we can see here, if I look at the data couples, we're sending in the pay rate and the hours worked, and we're getting the gross pay back. Now the module that called calculate gross pay has the responsibility for sending the pay rate and the hours worked, and has the responsibility for receiving the gross pay. If I have a look at this one, when this one is called, the module that calls it is responsible for sending it the pay rate, the hours worked, and the tax details, and is responsible for ensuring that it has an area to store the deductions and the gross pay. For this one here, the parameters, well, we've got two input parameters and we have one return value. For this one, we have three input parameters and two return values. Now we're going to ignore the fact that it's quite difficult with a function to actually have these two return values as they're shown here. But there are ways around that, which we can discuss some other time. But the key is, if we're looking at the design now and we're looking at data couples, what we can say is this is a good kind of data coupled module, in the sense that the thing calling it is only going to send it a couple of things and it's going to receive one back. This one, well, not as good, because it's got to send three things and two things are actually going to be returned. So in terms of design, this one's a better design. If we also quickly look, this one's only doing one thing, look, calculating the gross pay. So cohesively it's also better. If we have a look at this one, well, that's calculating two things. And you find if it's going to be doing two things, it's highly likely you're going to have more data couples in any case. Let's now look abstractly at the type of functions and function calls you can expect to see in a structure chart design program. Well, here you can see I've got a call to a function, and I've just put the name function name in there so we know we're dealing with the function. And it's returning a parameter to the calling module. Now you've seen an example of this when you read a record from a file system. Another kind of function call would call a function to which you send an input parameter and it returns a value. It has a return value, a return parameter. This is an example of a good module, because what you're doing here, you're sending it one parameter and you're getting one parameter back. And you've actually got a function name there, and providing that is cohesive, i.e. it has one task, that would be a well-designed function, a well-designed module. We have another one here where you have a function name, you send it an input parameter, and what it does in these circumstances is simply display that parameter on the screen. In other words, nothing is returned from this particular function. It carries out a task for us. Here's another call to a function, and this particular function will say it's going to do one task, but but we can see there are no input parameters and there's nothing being returned from the function. Now this kind of function would perform a task. Let's say you were playing a game, and at the end of the game when it quits, you simply wanted to put some closing captions on the screen which said something like, "I hope you enjoyed the game, please return later." So in fact it doesn't have any parameters that you pass to it. All the code for performing its task is inside the function, and it doesn't require any parameters, and it doesn't return anything either. Now here we can see another call to a function, and this particular function receives a parameter, it receives another parameter. In other words, it has two input parameters. The function does whatever it's going to do and returns a parameter. Now you've seen an example of this when we calculated the gross pay. Now this is another acceptable kind of design for a function where two things go in and one thing actually comes out. Now another function call here calls a function, it sends an input parameter, it sends another input parameter, but nothing is returned. You might see this kind of thing in a structure chart as well. And of course what might happen here, you might be sending it two things to be displayed on the screen or two things to be saved to a file system somewhere. What you're looking at here are some typical function calls and some typical parameter passing. Now the one that represents the best kind of design is this one here, providing this is just one task. In other words, the function carries out one task. And the aim is to try and write all your functions like this. Now, of course, you don't always need these kind of functions here. You know, you might just simply want one of these where it displays something on the screen when the game comes to an end. Let's go on and take this discussion a little bit further. When we're designing our programs, when we're doing stepwise refinement, and when we're drawing the structure of our system using a structure chart, what we should be attempting to do, create modules that perform one task, ideally with one simple input parameter that returns one simple data item. In other words, we're hoping that our structure charts are populated by these kind of calls here, where you call a one task function and you send to it an input parameter and it sends a return parameter back. That's kind of the aim. You can't always achieve this, by the way, but that's what we're aiming for. We're aiming for a structure chart that when you look at it has this kind of calling. One task functions are being called that take one input parameter and return one value. Something else that is acceptable is to create modules, i.e. functions, that perform one task ideally with one or two simple input parameters that return one simple data item. For example, if we have a call here that calls a one task function that sends it an input parameter, sends it another input parameter and has one thing returned, this is an acceptable thing to see throughout your structure chart when you're designing your computer program, your computer system. But we should go forward when we're thinking of designing our structure charts, which are going to implement the specification that we've been given, in this way. That's what we're striving for. We're striving to see lots of these in our structure chart. If we see this kind of thing in the structure chart, what we can say about this function is it has good cohesion, because it's only doing one thing. It has a good level of coupling. It's taking one thing in and it's only returning one value out. So we can say that this is what we can describe as good cohesion and good coupling. Now, as an aside, there's a lot more to cohesion than coupling that I'm suggesting with my description so far in this particular video. Now, there's something I wish to stress here. This video has looked at non-object oriented techniques for design. The structure chart does not apply. It's not much use when you're going to design your program as a community of communicating objects, where those objects are based upon classes. So I really must stress that. But if you're going to write your program without using classes, without using objects, then a structure chart is one way in which you can design the overall system. Now, this video has been about the design of a function, and clearly what I've been talking about here is how that function looks like in a structure chart. In other words, It's going to be called, it's going to do one function on one bit of data, and it's going to return a value based upon what the task was in that particular function. I've not talked about the algorithm that's inside the function. It's not that kind of design I've been discussing. I've been discussing when you put together your structure chart and you decide what all your functions must be, you should be going for a function that has one task to be carried out on one bit of input data and one bit of output data. You can't always achieve that for all of your functions, but that should be your kind of guiding way forward to produce a well-designed computer system. Why? Because they're easier to test. Now, if we consider the equivalent of a function in an object, it's the method. And we're going to have a look at methods later in the playlist when we get on to objects. But one of the things to bear in mind here, a method should also perform one task, ideally with one simple input parameter that returns one simple data item. But we can talk about methods a little bit later in the playlist. Check out the supporting website for these videos and also consider subscribing to the YouTube channel. Also consider subscribing to the Google Plus circle that relates to these videos. In addition, consider following me on Twitter, where you will get a tweet every time I have completed and uploaded a new video. The link to my Twitter account can be seen both on the YouTube page and on the supporting website.